they're giving us a function, and I'm just going to start graphing it because it asks us to analyze the graph, and there's some pictures of the graph. So I'm going to say the function is 2 over the quantity 2x squared minus x minus 3, and we're just going to hit the graph. Bless you.
Thank you.
All right, so now here we have some behaviors. Remember our function was f of, let me break that in red so we can see it a little better. Oops, that's not red. F of x is equal to 2 over the quantity 2x squared minus, what was it again? X minus 3. So now we're looking at the graph and we're going to talk about what's going on here. First and foremost, we have some vertical asymptotes. Where did those vertical asymptotes come from? Can somebody tell me?
Vertical.
They're what? Analytically, if I wanted to prove those, what would I do?
Look at the 2 terms.
Factor out the bottom of the denominator.
Yeah, it's when the denominator does what?
Which is 0.
Equals 0. So, and I would factor the denominator to find the zeros. So what I'm going to do is I'm going to find the zeros of the denominator by putting the first term here and the last term here. All right. Now to get this, I have to say 2x times 1x. And then I got to do a 1 and a 3. And I got to do it in a way that they don't, the middle term has to be negative x. So if I put a 1 here and a 3 here, over here I'll get a 3x. And over here I'll get a 1x. One of these terms has to be negative. Oh wait, I take that back, I'll get a 2x. This will be 2x, right? One of these terms has to be negative. It has to be the negative 3 because the sum of these two terms has to be negative 1x. So what happens is this whole thing factors out to, the numerator factors out to 2x minus 3 times x plus 1 cannot equal 0. So that's this whole thing factored and set equal to 0. So then if I set both of these equal to 0, then I get x cannot equal positive 3 over 2 and x cannot equal negative 1. Hey, guess what? This is about 1.5, or x cannot equal 3 over 2. And guess what this is? X cannot equal negative 1. Whoops. That was bizarre. Oh, I got my thing up, that's why. Oh. Let's just delete that. So this whole thing right here, x cannot equal negative 1. Right? That's the first thing. And behaviors. We got to look at the limit of this. Well, the limit of this, we really only have to look at the first two terms. In other words, I want to think, what is the limit of this as x approaches infinity? But I'm really only going to look at 2 over 2x squared. The 2's cancel out. And really what I'm looking at is the limit of 1 over x squared. If I plug a really, really big number into 1 over x squared for x, what do I get? 1 over a really, really, really big number squared. If I have one pizza and I divide it into 1 trillion slices, how big is the slice? 0. So this thing is going to approach 0. Okay? Now, if I look at the limit of this function as x approaches negative infinity, I'm going to get negative infinity squared, which becomes what? A positive infinity, right? And 1 over infinity is equal to 0. Okay? Guess what? EM behavior approaches 0. That's all they wanted us to do. Basically, on every problem, we kind of do the same thing every time. Okay? Now, the only other thing is a y-intercept. The y-intercept is not that easy to determine, but the y-intercept occurs when x is equal to 0. So remember that your y-intercept would be f of 0, which would equal to 2 all over. This term would go to 0, this term would go to 0, and we'd be left with negative 3 or negative 2/3. What do you think this number is right here?
0.
Negative 2/3.
Negative 2/3.
X is 0, but y is equal to negative 2/3. And that's about it.